What's up, everybody? It's Dan from SageMathTutoring.com. I am working on a review sheet for my student who is doing pretty good, but he's got a quiz coming up, and this is a review sheet that has to do with functions and things like that, which can be confusing for a lot of people. I say we just dive right into it. So, Ramona's Garage charges the following labor rates. All customers are charged with at least 0.5 hour. Okay. So, let's see. It's often helpful to think of these real world situations in terms of the XY coordinate plane. So that could be X, that could be Y. And at the end of the day, um, the hours could actually be the X um, axis and the labor could be the Y axis. Now, it's typically a good idea to see time as the X axis. So rather than actually label this as X and this is Y, what I'm going to do is I'm going to label this as H and label this as L for labor. Now, for my student at home, just know that you do not have to do this. You don't have to draw a graph or anything, but I'm still drawing it just to give everyone the idea of what's happening here. The bottom line is there's a such thing as 1 hour going by, there's a such thing as 2 hours going by, and then there's a half an hour, which is right there, there's an hour and a half, which is right there, and then there's 2.5 hours right there. Similarly, there is labor, so that goes from 60 to 90 to 120 to 150 to 180. So maybe you could imagine the labor as going up by 100. That would be 200, and we have a point at 0.5 comma 60, so that might be right around there. And then we have another point. I'll make that red actually. Then we have another point at 1 comma 90. That would probably be right around there. And we have another point at 1.5 comma 120. That would be right around there. Another one at 2 comma 150. That would be right around there. And another one at 2.5 180. So that would be around there. Now, in a perfect graph, this actually might be a straight line. I'm not exactly sure. Well, actually, I am sure. It's going to be a straight line for sure. So for my student at home, just know that you don't have to graph it, but nonetheless, this is the big picture of what's happening. Notice how the hours represent the X coordinates and labor represents the Y coordinates. I mean, ultimately, that's what I'm getting at here. So they want us to write a linear function for the data in the table. At the end of the day, what they're looking for, at least at this stage in the game, is y equals mx plus b, where that's the y-intercept, and this is the slope. Now, for something where the y-intercept is not obvious, like for example, if you look at all this, the y-intercept is not obvious, okay? So we're going to have to find the slope first. Now, the slope formula, as many of you probably remember, is m equals, my student at home likes to do it as y1 minus y2 all over x1 minus x2. And we want to pick 2 points that are relatively easy to work with. I'm going to pick these two. And it's often going to be the case that, you know, one of the points we're going to call x1, y1, another point we're going to call x2, y2. And let's have the first point be 1 comma 90. That's fine. We have another point called 2 comma 150. And in that case, we'd be dealing with a slope formula composed as the following. It would be m equals, let's see, y1 minus y2. That would be 90 minus 150 all over x1 minus x2. That would be 1 minus 2. 90 minus 150 is negative 60. 1 minus 2 is negative 1. So the slope turns out to be negative 60 over negative 1, which is really just positive 60. So in a way, we've already made some headway constructing our linear function. In fact, since I say function, I'm going to call, instead of writing y, I'm going to write f of x. So for my student at home, When they mention function, maybe just write f of x. Okay. Remember, f of x and y are kind of interchangeable. So for this part, instead of writing mx plus b, I'm actually going to write 60x plus b because we already know what the slope is. It's 60. We figured that out by choosing 2 points, plugging them into this formula, and then finding out the slope. Okay. Now our new task is to find the y-intercept. Once again, it wasn't obvious by looking at the table what the y-intercept was. So we will have to kind of pick one of the points. I'm going to go with this one. You just pick one of the points, it doesn't matter which one, and you substitute 1 in for x and 90 in for y, or you could say 90 in for f of x. So instead of f of x, I'm going to write 90, and then we have 60 times x, but instead of x, I'm going to write 1, okay, and then we have plus b, okay. Then we're going to go on a mission to solve for b. Now, clearly 60 times 1 is just 60, so we have 90 equals 60 plus b. At that point, we're going to want to subtract 60 from both sides, and we end up with b equals 30. So we just found our y-intercept. We found our slope from before, and now we just found our y-intercept, which allows us to finally satisfy the first question, which is to write the linear function for the data in the table. Well, I'm going to write that in red. It's going to be f of x equals 60x plus 30. Okay? That is a linear function that lines up with the data in the table. Okay? Slope of 60, we found the slope first by using this formula, by picking 2 points. And then we went on another mission where we found the y-intercept by reconstructing the function with the slope. We found the slope, picking one of the points, substituting 1 in for x, substituting 90 in for f of x, and then we have 90 equals 60 times 1 plus b. We solved for b, and then we weren't done. We have a slope and we have a y-intercept. Then we have to write the final function with the slope and the y-intercept. Okay, so hopefully that makes sense. I'm going to erase this stuff. So for my student at home, you might want to pause the video, make notes if necessary. I will be erasing this. Okay, so the second part says a repair job took 4 hours and 15 minutes and required $390 in parts. What's the total cost? Now, we constructed this function from before, but I'm going to reconstruct it. So instead of f of x, I'm going to write f of h, where it's 60 times h plus 30. Now this represents how much the labor costs, okay? So at this garage, if the labor takes a half hour, it's going to be $60. If the labor takes an hour, it's going to cost $90. If the labor takes an hour and a half, it's going to be $120, okay? So this f of h, this sort of function that we constructed, has only to do with labor costs. It has nothing to do with how much the parts cost. So basically, for my student at home, just understand, once you're driving, okay, and you got to take your car to the garage or whatever, they're going to charge you not just for the labor, because they have to do work, right? They hire employees to fix the car, and you got to pay those employees, right? So that's the labor cost, and that would be this, okay? But they also are going to charge you for the parts. Like they might have to order new tires or something, right? And that costs them money, so they got to charge you money, right? So the total cost of a job that takes a certain amount of time and has $390 in parts, the total cost, well, that's going to be the cost for the parts and the cost for the labor, right? Cost for the labor. So I'm going to write, total cost, big T over here. And we know that the cost for the parts for this, part B is $390. So it's going to be $390 plus the cost for the labor. Now the cost for the labor is over here. So we're going to say 390 plus f of h. Now at the end of the day, that is going to be our answer, okay? It's going to be 390 plus f of h. But f of h, we got to figure out. The repair job took 4 hours and 15 minutes. Well, how much is the labor going to be if the hours is 4 hours and 15 minutes? Well, let's be very clear. Let's be very clear. 4 hours and 30 minutes. Well, isn't that 4.5 hours? Right? Because 30 minutes is a half hour. So 30 minutes is 0.5 hours. Okay? Now, half of 30 is 15 minutes. So 4 hours and 15 minutes, well, that's going to be 4 hours and a quarter of an hour. So that's going to be 4.25 hours. Now, if you have to pause the video and think about that, feel free. Now, for my student at home, you could pause the video and think about it, okay? Or you could just, recognize that, oh, okay, well, if 30 minutes is 0.5 hours, then clearly 15 minutes is half that, so that's going to be 0.25 hours. Or you could just simply memorize the fact that, 15 minutes is 0.25 hours, okay? So the reason why we need to know that is because, this job took 4 hours and 15 minutes, so that's 4.25 hours. That tells us what to put in for H here, okay? If we want to know what the labor costs were, well, we got to plug in, we got to substitute in 4.25 in for H over there. So I'm actually going to bring that down here. We're going to do that. It's going to be F of 4.25. Okay, that's the fancy way of writing it. We're finding F of 4.25. And what that means is we're going to go 60 times 4.25 plus 30. Now, 60 times 4.25 is 255. So it's going to be 255 plus 30, and that's going to be 285. Now, for my student at home, just know there's always a slight chance I might make a careless mistake, but so far I don't think I have. So anyway, the bottom line is the total cost is most definitely going to be 390 plus the total cost of labor. Now, in reality, the cost of labor for 4 hours and 15 minutes is going to be F of 4.25. And then I'm going to bring that up here. That turned out to be 390 plus 285, because we found out what F of 4.25 is. It's 285. So that's going to be the final answer. The total cost is the cost of the parts plus the cost of the labor, which turns out to be $645. That's how much it costs to do that whole job. Hopefully that makes sense. For my student at home, pause it, rewind it, watch it again, put it in slow-mo if you have to. But I will say this is a relatively challenging problem. They don't make the Y-intercept obvious. You got to use the slope formula to find the slope. Then you have to use your function that you found in part A as a tool to find the part B. And in part B, you had to realize, okay, well, there's $390 associated with the cost in parts, but then there's also going to be the cost for the labor, and we get the cost for labor by using the earlier function. Okay, so hopefully that makes sense. Okay, given g of x equals f of x plus k, what value of k transforms the function f into g? Okay, so here's function f, apparently. And then there was plus k. So anytime there is a plus something on the outside of the f of x, that is a vertical shift. Okay? That means you take the original function and then you move it up or down. Okay, now here's the original function. This is f. It says f of x. So here's f. This is the original function. And then there's a vertical shift. Well, clearly it went down. So that means k is negative. I know it says plus k, But if you started here, and that's your f of x, and then you went down, well, that means that the vertical shift went down, and that means that k is negative. So if the vertical shift is positive, it goes up, then k is going to be positive. If the vertical shift goes down, then k is going to be negative, okay? So in order to find out what k equals, well, first of all, we know it's going to be negative. So I'm just going to write negative because I know it's going to be negative something. But the question is negative what? Negative what? Right. So all you got to do is just pick one point, any old point, doesn't matter which one. Let's pick this point, and then ask ourselves, okay, here's a point on the original function. How many units did it go down? Well, it went 1, 2, 3 units down. So it will be negative 3, negative 3. Erasing this is annoying because my eraser is small, but that's fine. So negative 3. Boom. Done. That is k. Once again, original function right here. K represents a vertical shift. We clearly went down, therefore k is negative, and we went down 3 units. Had this been the original function and we shifted upward 3 units, k would have been a positive 3. Okay? Okay, given f of x equals blah and h of x equals blah, what are the slope and y-intercept of the graph of function h? Okay, well, h is apparently negative 5 times f of x, right? Let me say it again. Let me write it over here. H of x equals negative 5 times whatever the heck f of x is, right? I'm going to wrap f of x in blue. And you know what? You know where f of x is? You know where f of x is? Right here. There it is. That's f of x. Oh, look, f of x equals negative 7x plus 9. Wow. I guess that means I can rewrite this as negative 5 times what? You guessed it, negative 7x plus 9. I'm going to keep it all in blue. This is going to be in blue. F of x, anything that has to do with f of x, we're keeping in blue. Here it is. Right? Doesn't f of x equal negative 7x plus 9? Right? So when I say h of x equals negative 5 times f of x, what I really mean is h of x equals negative 5 times this. Okay? So they want you to find the slope and the y-intercept of h. In other words, find the slope and y-intercept of this thing. Well, we're almost there. I mean, it looks a little bit messy, like a bunch of gobbledygook here, so we're going to clean it up a little bit. Let me erase that because that contributes to the gobbledygookness. What you have to do is you have to now distribute 5 into everything, or that negative 5 into everything. So this becomes negative 5 times negative 7x, so that's going to be positive 35x. It's going to be negative 5 times positive 9, so that's going to be negative 45. So h of x, really, you could say, is equal to 35x minus 45. So then when they ask for the slope, well, that's obvious. It's right here, right? So basically, we took this gobbledygook situation and we simplified it so that it was in y equals mx plus b form. It's clear that the slope is 35. And it's clear that the y-intercept is negative 45. Okay, I think it's possible that the teacher might be cool with you writing y-intercept as negative 45. Sometimes the teacher might prefer you to write 0, comma negative 45. Again, I have a feeling the teacher is going to be okay with that, though. Okay, and you got that from here. All right, given f of x equals 8x plus 1 and g of x equals blah, 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 which equation represents g? So, you know, this one was a little bit more straightforward because it's like negative 5 times f of x, right? This is just normal looking, whereas this is f of x minus 2. So the reality is when it comes to this one, which is a little bit more complicated, we have to figure out, okay, well, what is f of x minus 2? Well, we know that f of x is this. It's 8x plus 1. So f of x minus 2 going to be the same thing, only with x minus 2 plugged in. So we have 8 times x minus 2 plus 1. And then all we'd have to do really is, to simplify that, is to distribute that, so we have 8 times x is 8x, 8 times negative 2 is negative 16, plus 1. So that becomes 8x minus 15. So in reality, f of x minus 2 is equal to 8x minus 15. So when they say g of x equals f of x minus 2, well, really what they're saying is that g of x equals 8x minus 15, right? Because we totally figured out what f of x minus 2 is. So this is the answer. Answer choice D is the answer, therefore. Okay, 8x minus 15. Now, quick recap. They want to know which equation represents g. You look at g and you're like, okay, well, what is g of x? G of x is f of x minus 2. Okay, well, what the heck is that, right? Well, let's look at, this is f of x. F of x equals 8x plus 1. Well, f of x minus 2 is going to be the same thing, only we're plugging in x minus 2 in for x. And then we have to distribute and simplify, etc., and we end up with 8x minus 15. Hopefully that makes sense. Okay, for f of x and g of x, describe each transformation, then write the equation of the transformed function. Okay, so this is f of x, it's 2x plus 1. G of x is this thing, okay? So let's focus on row A, f of x minus 5. Well, like I said in an earlier slide, anytime you have a number on the outside of f of x, like, that's either being added or subtracted, that's a vertical shift either up or down. So that's a vertical shift down, I'm going to call VS, down 5 units, okay? Now, all you have to do to write the new function is to take f of x, which was, 2x plus 1, and be like, okay, well, it's going to be f of x minus 5. So it's going to be 2x plus 1 minus 5. And that turns out to be 2x minus 4. So we have 2x minus 4. So, don't be too confused about this. We're just taking the original function and we're subtracting 5 from it, ultimately. That's all we're doing, right? 2x plus 1 minus 5. And then we simplified it. Okay, so that should hopefully make sense. So that's how that one works. Looking at the next one, g of x plus 4. Well, for my student at home, I do believe that you should be able to do that. G of x plus 4. Well, what is that? That is a vertical shift upward 4 units. And guess what you have to do? You have to take g of x and add 4 to it. You have to take this g of x and add 4 to it. Now I'm going to be kind of a dork and represent that process on both sides. So that's going to become 1/3 x plus 2 plus 4, right? So it's the original function in black, only we're now adding 4. And what that results in is, 1/3 x plus 6. So that's what that's going to be, 1/3 x plus 6. Okay, so then they have the next thing, which is coming up after I erase stuff. So we have 3 times g of x. Okay, so that's anytime you have something that's being multiplied to the original function and it's out front, that's a vertical, either a vertical stretch or a vertical compression, okay? Now, if it's a fraction, it's a vertical compression, okay? If it's a fraction like this, I should say. If it's a fraction like that, then it's a vertical compression. If it's a number that's the absolute value of which is greater than 1, then it is a vertical stretch. So if you think about it, it's kind of intuitive. If it's like a big number, it's getting stretched. If it's a fraction, it's getting smushed. You could think of it that way. Now, when we have a vertical stretch, we call it a vertical stretch. When we have a fraction, we call that a vertical compression. Now, I already used VS for vertical shift, so I'm already seeing the problem. We're going to call that V shift, okay? These were shifts upward, whereas this is going to be a vertical stretch. I'm going to use STR, okay? That's STR. Now, you could say by a factor, okay, by a factor of 3, okay, because it is a 3 that's in front of there. So what this results in is, 3 times g of x. So that means we're going to do 3 times g of x, which is equal to 3 times, the original g of x, which was 1/3 x plus 2. Then we can distribute the 3 into both of those things, and we end up with, now, 3 times 1/3, right? 3 times 1/3. Let's think about that. We're going to take it down here. 3 times 1/3. Well, my student at home hopefully realizes there's an invisible 1 under there. And then if you wanted to, you could multiply straight across. Now, you could cancel these, but let's just multiply straight across. 3 times 1 up top is just 3. 1 times 3 down below is just 3. So we have 3 over 3, which is really just secretly 1. So when I multiply this 3 times the 1/3 x, it's just going to be 1x, also known as x. But then I have 3 times this 2, so that's going to be 6, so that's plus 6. Okay? So 3 times g of x actually equals x plus 6 after simplifying, and that's what they want to know right here. Okay? So then they have 1/2 f of x. Well, that is, as I had sort of stated before, that's going to be a vertical compression, okay, because it is a fraction, right? It's a fraction. So therefore, I can write v comp, okay? And we can say by a factor of 1/2, okay? So what do we do? Well, we multiply 1/2 times f of x. F of x is over here. We're going to go ahead and multiply 1/2 times f of x. And therefore, it's going to be 1/2 times 2x plus 1. And that ends up becoming such that we distribute. Now, 1/2 times 2x, that's going to be 1x, aka x, for the previously mentioned reason before. You could always work that out. For my student at home, if you want to go off to the side, just multiply 1/2 times 2, off to the side and confirm that it becomes 1, go for it. But at the end of the day, it's going to be 1x, also known as x, and then we have 1/2 times 1, which is just 1/2. So really, that ends up becoming x plus 1/2. Okay, so that's how that one works. Now let's focus on this. Use the above functions to answer the following multiple choice questions on the next 4 slides and to write the new function h of x. Okay, so what I'm going to have to do, therefore, is I'm going to save this whole thing right now. I'm going to save this because we're going to need these functions. Apparently, according to this thing, we're going to need these functions to, do the rest of the problems. Okay. So here's one of the problems. And I'm going to paste this old thing here. We're going to use that to figure out this guy. All right, we'll make this kind of nice looking, nicer looking. Which of the following describes the transformation f of x minus 5? Well, f of x minus 5 is right here, right? We already we already did that, didn't we? So we already know that that's a vertical shift downward 5 units. We already talked about that, right? So, I don't know. To me, this is kind of easy. It's a shift 5 units down. Ding, 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 ding. Kind of feel like that's easy, to be honest. I mean, we already described it. So in a way, these questions are just asking us to describe it again. And that's what we just did. Okay. G of x plus 4. Let's get our old, notes in, right? Make our lives easier by focusing on the work that we've already done. So they ask, which of the following describes the transformation g of x plus 4? Well, that's right here, right? We already talked about it. It's a vertical shift upward 4 units. Oh, let me guess, it's that one. Boom, done. So easy, so easy. A shift 4 units up. And just in case, let's not get too cocky. Um, a shift 4 units to the right, it's definitely not that. Vertical scaling by a factor of 4, no, definitely not that. A shift 4 units to the left, no. No, 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 no. It's definitely this one. Okay, and then they say, oh, write the new function, h of x. All right, here's the deal. I should have done that on the last slide, but let's just not worry about it. G of x plus 4, basically they just want you to write this thing, 1/3 x plus 6. Okay, 1/3 x plus 6. So that's the new function. Okay, they're calling this new transformed function. It used to be g of x, but now it's g of x plus 4. And by the way, we're going to call this thing h of x. Okay, that's really what it is. H of x equals that. Okay, then there's this one, and hopefully my student at home can kind of see how, because we already kind of did the legwork before, it's actually pretty easy from here on out because we already pretty much did everything. Which of the following describes the transformation to 3 times g of x? Well, here it is. Well, we called it a vertical stretch by a factor of 3. Well, they're calling it a vertical scaling, just so you know. I've actually never heard a teacher call it that, a vertical scaling. Usually they say stretch, but that's fine. You know, just get used to the way that your teacher says it. This is a scale factor, okay? So I can understand why they would use the word scale. Sometimes they call it a scale factor. 3 would be a quote-unquote scale factor. So it makes sense that they would call it a vertical scaling. So just know vertical stretch and vertical scaling are literally the same thing. Okay, so don't worry too much about that. And we already described it, you know, here it is. And we already went through the motions to figure out what the new function is going to turn into. It's going to become x plus 6. So guess what? H of x equals x plus 6. That's the new function. H of x is code for what's the new and improved function as a result of applying this transformation. Okay, so that's how you do that. Okay, so then we have this one right here. And let's bring our little reference guide here. Okay, I know this is kind of shaky looking maybe when I move everything. Which of the following describes the transformation of 1/2 f of x? Okay, so I had referred to it as a vertical compression by a factor of 1/2. Now, the reality is that it's a vertical scaling by a factor of 1/2. So instead of compression or stretch, just replace it with the word scaling. Okay, vertical scaling by a factor of 1/2. And the next one is clearly wrong. It's not a shift 1/2 units up. It's not a shift 1/2 units down. It's not a shift 1/2 units to the right either. Okay. In fact, that would be a horizontal shift, and we haven't even gone there. And this is a horizontal scaling, so nothing in any of this has anything to do with horizontal anything. Okay, which actually makes me wonder if the teacher has even gone over horizontal transformations with my student at home. There's a chance my teacher has not even gone over horizontal transformations. It appears the teacher has gone over vertical transformations, vertical shift upward, vertical shift upward, vertical shift downward, vertical shift upward. This is a vertical stretch. This is a vertical compression. Uh, my student's teacher apparently is using the word scaling instead of stretching or compressing, pressing, and that's fine. But for my student at home, just know that so far everything has been vertical. And I will say, just as a rule of thumb, anytime you're dealing with numbers outside of the parentheses, okay, it's going to have to do with something vertical. Okay, I'll just leave it at that. Anytime you have numbers outside of the parentheses, you have -4 outside the parentheses, +4 outside the parentheses, you have a 3 that's getting multiplied outside the parentheses, you have a 1/2 that's getting multiplied outside the parentheses, that's going to have something to do with vertical, okay? And I'll just give my student at home a heads up. Anytime there's shenanigans happening inside the parentheses, that's when you have to worry about horizontal stuff. But again, it appears my student's teacher, or if you're my student listening, it appears your teacher is not yet focusing on horizontal stuff, I guess. okay? I haven't seen anything related to that on the review sheet so far. So anyway, hopefully that makes sense. Let's finish this by satisfying the last part. Now write the new function, h of x equals, well, it's vertical scaling by a factor of 1/2. We already figured out what that's going to be. It's going to look like that, okay? Now for my student at home, maybe you forgot how we found that, right? Maybe for my student at home, you forget how we found any of this stuff. Well, the solution is simple. Just rewind the YouTube video, go over it again, and make sure you understand it. You know, again, you could speed up the YouTube video. You can slow it down if you have to, okay? Anyway, I hope that makes sense to my students, so good luck on your quiz. For those of you who are not my students and you watched it, well, good luck to you as well. Hopefully it made sense. There's always a chance I made a careless mistake. And in fact, if I did make a careless mistake, go ahead and comment down below and let me know. And, you know, I'll make notes mentioning, you know, what to look out for with a timestamp. So anyway, uh, good luck to everybody, and I will talk to you soon. Take care.